Diabetes mellitus, which is associated with elevated blood glucose levels, is on the rise globally and needs to be managed medically and through lifestyle changes. Insulin degrading enzyme, IDE, is a large zinc-binding metallopeptidase that regulates insulin levels to maintain glucose homeostasis. Elevated levels of IDE have recently been reported in patients with metabolic syndrome. To decrease insulin degradation, the inhibition of IDE has previously been suggested. Nevertheless, a majority of the developed inhibitors bind to its zinc-binding domain and therefore can inhibit other essential metallopeptidases which may have toxic effects. As IDE has also been shown to interact with and mediate the cellular entry of the varicella-zoster virus, researchers from Tel Aviv University, Israel, conducted a study to develop a specific inhibitor based on the virus. First, based on the interaction domain of the virus, they computationally developed a short peptide called ADT21, which binds to a zinc-independent domain of IDE. They tested the stability and conformation of the peptide in a physiological aqueous solution. Next, using computational algorithms, they evaluated the interaction of ADT21 with IDE and other metalloproteases and confirmed its binding affinity and specificity. Further, they observed a significant decrease, i.e. 61%, in IDE activity in vitro. The peptide, administered nasally, was able to considerably decrease insulin-related defects in mouse models of type 1 diabetes and also improve glucose tolerance in obese mice. Moreover, these effects were paralleled with an increase in insulin levels and a decrease in pro-inflammatory factors involved in diabetes. Overall, these findings reveal a highly specific IDE inhibitory peptide that stabilizes insulin levels and modifies the immune response against insulin, thereby creating avenues for designing novel anti-diabetic therapies.